right? So next topic, extraction of crude metals. So for the purpose of extraction of metals from the concentrated ores, we can group all the metals into the following the three categories. They are metals of high reactive. So they are potassium, sodium, calcium, magnesium and aluminum. The second category is metals of medium reactivity, zinc, iron, lead, copper. Metals of low reactivity, mercury, platinum, silver, gold. Here one important thing is the extraction of metal from its concentrated ore is essentially a process of reduction. A process of reduction of the metal compound present in the ore. The method of reduction to be used depends on the capacity, it depends on the reactivity of the metal to be extracted, right? So reduction is very important process for extraction of metals. So three different categories of metals have different processes to extract them from their respective concentrated ores. So let's understand the extraction of high reactive metals. So for the process of reduction, we have to use one element. So that is carbon. So carbon is a good reducing agent. So carbon is used as a reducing agent to extract the metals from their respective concentrated ores. But a metal called as manganese, which is higher reactive than zinc. So it is extracted or it is reduced by aluminium instead of carbon. But the copper is a low medium reactive element, so reduced by carbon as well by heating in the air. So these are the some points. Let's understand extraction of high reactive metals. High reactive metals such as potassium, sodium, calcium, magnesium, aluminum are placed in the high in the reactive series in the upper part. So the oxides of high reactive metals are very stable and cannot be reduced by the most commonly reducing agent carbon. So this because of these metals have more affinity for oxygen than the carbon. So carbon is unable to remove oxygen from metal oxides and hence cannot convert them into free metals. Thus, the highly reactive metals cannot be extracted by reducing their oxides with the carbon. So, even carbon is an excellent reducing agent, but in case of highly reactive elements, highly reactive metals like potassium, sodium, aluminum, magnesium. So, these oxides, as earlier we discussed, highly reactive metals available in the combined state with chlorides and oxides. So, but oxides cannot be reduced by the carbon because of these metals are very have affection with oxygen than the carbon. So, we cannot extract these metals by reduction with carbon. The high reactive metals are extracted by the electrolytic reduction of the molten chlorides or oxides. So we can use one method we can call as electrolytic reduction. So electrolytic reduction of metal chlorides So the highly reactive metals are extracted by the electrolysis of their molten chlorides or the oxides. During electrolysis, the negatively charged electrodes called as cathode, the positively charged electrode is called as anode, as already we discussed in the chapter chemical reactions and equation, especially electrolysis of water, decomposition of water by electrolysis. So during the electrolysis, the molten salts, the metals are always produced at the cathodes. When a molten metal chloride is electrolyzed by the passing electric current, the pure metal is produced at the cathode. When molten metal chlorides, when molten metal chlorides are electrolyzed. So what happens when the molten metal chlorides or molten metal oxides are electrolyzed by passing electricity. So what is meant by electrolysis? Electrolysis is the reaction, one of the chemical reaction carried out by passing electricity. So when a molten metal oxides or metal chlorides are electrolyzed by passing electric current, the pure metal is electrolyzed by metal chlorides as well metal oxides. Metal chlorides as well as metal oxides are electrolyzed by passing electricity. The pure metal is formed. At cathode. So cathode is an electrode which is connected to the negative terminal of the cell or battery, whereas the anode is the positive electrode which is connected to the positive terminal of the battery. So for example, if a simple circuit diagram like this, so this is one electrode and this is another electrode, and this is called as anode and this is called as the cathode. This is called as anode, this is called as the cathode. So plus minus, the electrode which is connected to the terminal is called as cathode, which is connected to the polymer is called as anode. If you take magnesium metal chlorides are metal oxides, molten metal chlorides are metal oxides. So metals are formed at the cathode. And the remaining are formed at the anode. So electrolysis is the chemical process happened. A compound is separated by passing electricity. There are two electrodes, one is cathode and another one is the anode. Cathode is the electrode which is connected to the negative terminal, of the battery, and whereas the anode is the electrode which is connected to the positive terminal of the battery. So whenever we take molten metal chlorides and oxides are electrolyzed by passing electricity, the pure metal is formed at the cathode because it is negatively charged. So then whereas the metals are the positively charged, already we discussed, because by losing electrons. So positive charge is formed, this positive ion is migrated or transferred to the cathode. Then the chloride or the oxides are the negatively charged, so they are migrated or they are transferred to the positive charged electron. So the highly reactive metals like potassium, sodium, calcium, magnesium are extracted by the electrolysis of their molten chlorides, whereas aluminum metal is extracted by electrolysis of its molten oxide. So, potassium, sodium, calcium, magnesium are by the chlorides, whereas the aluminum is by the oxides. So, extraction of sodium metal. Let us understand one example. So, extraction of sodium metal. Sodium metal. Extraction of sodium metal. So, how do we get sodium? Extraction of sodium metal from its respective ore. So generally sodium chloride, common salt or the rock salt is the ore for extraction of sodium. For extraction of sodium. How the sodium is extracted. Sodium metal is extracted by the electrolytic reaction or the electrolysis of molten sodium chloride. Molten sodium chloride. When the electric current is passed through molten sodium chloride, it decomposes and forms sodium metal and chlorine gas. So molten sodium chloride. So for example, this one taken as molten sodium chloride. So electrolysis of molten sodium chloride. So this sodium chloride NaCl. Sorry for any inconvenience. Extraction. Here I will have it. Easy. Extraction of sodium chloride. Extraction of sodium from its respective ore. So, sodium chloride is the ore. When it is involved in electrolysis, it forms sodium and chlorine gas. So, it is a gas, and sodium solid 2NaC. So molten sodium chloride. So involves electrolysis, electrolytic reduction. It reduces liquid state of sodium and chlorine. So sodium formed at the cathode. Here the sodium is formed and the chlorine is formed at the anode. So what the reaction takes place when electricity or electric current is passed through molten sodium chloride. So while passing electricity through molten sodium chloride, so the following reaction is taking place. So what happened in the reaction? So the positive sodium are attracted to the cathode. So first of all, the sodium chloride is disassociated into Na plus and Cl minus ions. So and the decomposition of sodium chloride forms sodium ion as well as chloride ion. Sodium ion and as well as chloride ion. So this sodium loses one electron and cathode. At cathode. So already sodium is formed. So sorry, at cathode by the passing of electricity. By the passing of electricity, sodium chloride dissociates with forms ions. These ions. So Na plus 2 electrons to electron. So gain and forms Na. So at cathode sodium is formed. So NaCl is dissociated and divided into Na plus and Cl minus ion. So this here is Na plus ion is attracted towards the cathode because it is positive and it is negative. At this cathode sodium takes the 2 electrons, gain the electrons and forming neutral metal, and sodium is formed at the cathode. Whereas chlorine. So chlorine loses the 2 electrons and forms chlorine. So this is happened at anode. So the negatively charged chloride. The negatively charged chloride ion is attracted towards the anode and loses the 2 electrons and forms chlorine gas. This at the anode. The reactions happen at the cathode and the anode. At the cathode, the sodium ion is attracted towards the cathode, gain the electrons and deposited and forms a pure sodium at the cathode. Whereas chloride ion attracted towards the anode loses the electrons and forms chlorine gas. So chlorine gas is formed at the anode, positive electrode. Sodium metal is formed at the electrode at the cathode, which is negatively electrode. So in this for this extraction of sodium from the sodium chloride, we cannot use the aqueous solution. Aqueous solution of sodium chloride. Aqueous solution of sodium chloride is also known as the brine solution. We cannot use the brine solution for extraction of sodium from sodium chloride because of the reason the aqueous solution of sodium chloride obtained sodium metal. This is because electrolyte and aqueous solution of sodium chloride, then as soon as sodium metal produced at the cathode, it reacts with water. So if you take aqueous solution of sodium chloride, the sodium which is formed at the cathode immediately react with water and forms sodium hydroxide, which is a base. So that's why we cannot take aqueous sodium chloride solution for extraction of sodium, but we can take molten sodium chloride. Cathode will react with water present in the aqueous solution to form sodium hydroxide. Not sodium metal. So just like sodium metal, potassium metal is produced by the electrolysis of molten potassium chloride. Calcium metal is obtained by the electrolysis of molten calcium chloride. Similarly, magnesium metal is also extracted by electrolysis of molten magnesium chloride. As already we discussed before only, potassium, sodium, calcium, magnesium. Potassium, sodium, calcium, magnesium are obtained from their respective metal halide groups, chlorides. Sodium chloride, potassium chloride, magnesium chloride and calcium chloride. From these metals, from potassium chloride, potassium obtained. From magnesium chloride, magnesium obtained. From calcium chloride, calcium is obtained. But aluminium is obtained. From Aluminium oxide. So aluminium oxide is also called as alumina, and the most abundant ore for aluminium is bauxite. Bauxite is Al2O3. Bauxite is Al2O3. So bauxite Al2O3. Bauxite is Al2O3. So then extraction of aluminium. Extraction of aluminium. Extraction of aluminium. So aluminium is obtained from its ore. Bauxite. So it is Al2O3. So all sodium, potassium, sodium, calcium, magnesium from the chlorides, whereas aluminium from its extract from aluminium. Molten aluminium oxide contains free aluminium ions and free oxide ions. During the electrolysis of molten aluminium oxide, the following reactions. The positively charged aluminium ions are abstracted as usually. So aluminium oxide, it contains of Al plus 3 and O minus 2 ions. Al plus 3 and O minus 2 ions. Whereas sodium chloride contains Na plus and Cl minus ions. So the molten aluminium oxide divides aluminium plus 3 and O2 minus ions. So similarly, aluminium plus 3, it gains 3 electrons from the cathode and forms aluminium. This reaction takes place at cathode. Whereas oxygen O minus 2 loses 2 electrons and forms oxygen. This is takes place at the cathode. So finally, sodium aluminium oxide is dissociated and forms aluminium and oxygen. Go to formula number 2. Here 4 electrons. For 1 oxygen 2 electrons. 2 oxygens give 4 electrons. So aluminium. So 2Al2O3. The reaction we can write 2Al2O3. So by the process of electrolysis, it forms aluminium plus 3O2. So 4Al. 2, 4, 6 oxygen. This aluminium is formed at the cathode. Then oxygen formed at the anode. So highly reactive metals are extracted by the electrolysis process, by the electrolytic reduction, or by the process of electrolysis. Because of these highly reactive metals are available in the combined state with the chlorides and oxides. So carbon actually, which is a excellent reducing agent, but all these are not reduced by the carbon, because they are very affected with oxygen than the carbon. So carbon is not used as a reducing agent, for these highly reactive elements. So this is about extraction of highly reactive metals. So that's all for this session, and so nobody is commenting about any doubts. So because of maybe there is no direct interaction with you, maybe one of the reason. But so you have to post a doubt regarding to any subject, any topic which are already explained, right? So which is very helpful to you as well as helpful to me also. Thank you so much. Signing off.